Okay, let's unpack this. Think about your local creek, the one you drive past, maybe live near. Have you ever really stopped to wonder what's truly going on beneath the surface? Like what keeps it healthy or what unseen challenges it might be facing? Today we're taking a deep dive into this incredibly detailed report. It does exactly that for a really significant natural area, the Broad Run Watershed in Prince William County, Virginia. And this isn't just about, one local stream. It's a fascinating look at how an entire community assesses, protects, and plans for the long-term health of its vital water systems, our mission. To pull out the most important insights from this really comprehensive assessment, helping you understand the complex but absolutely critical world of watershed management. So we're looking at the Broad Run Watershed. To give us some essential context, what exactly is this watershed, and why was this particular assessment so important for Prince William County?
Yeah, well, what's truly fascinating here is just the sheer scale of it and the vision behind assessing it in the first place. The Broad Run Watershed, it's this massive natural system. It drains approximately 120 square miles in total. Now, of that, about 73 square miles fall squarely within Prince William County, which means it makes up roughly 20% of the county's entire surface area. Just think about that for a sec. 1/5 of the county's land is directly tied to this water system.
Wow, 20%, that's huge.
Exactly. So this 2012 assessment, prepared by Whitman, Record and Associates for the County Public Works Department, it was crucial. It aimed to be like a complete health checkup for the watershed, designed to evaluate its overall condition, look closely at stream channels, the whole network of stormwater management facilities, and ultimately identify potential capital improvement projects, things the county needed to budget for and build. Essentially, it was about creating a blueprint for the future of a major piece of the county's natural infrastructure.
Okay, that makes sense. But still, 73 square miles. With, 185 miles of streams and over 300 stormwater facilities,
Okay.
how do you even begin to approach assessing something that vast without getting completely, overwhelmed?
Right, and that raises a really important question. How do you tackle such an enormous undertaking efficiently? And the study, it actually offers a brilliant blueprint for that. The real genius of this assessment lies in its smart four-stage screening process. It methodically narrowed the focus. First, they didn't try to inspect everything. That'd be impossible. Instead, they used existing land use information, things like how much development, forest, or agriculture was present,
Yeah.
to strategically select 5 representative subwatersheds for a closer, more detailed look.
Oh, okay, so they sampled, basically.
Right.
Got a cross-section.
Precisely.
Yeah.
A good cross-section without trying to boil the ocean. Second, they did a desktop analysis using GIS mapping, other digital tools to identify specific stream segments and stormwater facilities within those 5 chosen subwatersheds, pinpointing where to send field crews. Third, the results from those, intensive field inspections then pinpointed exactly which streams and facilities needed maintenance or repair or even complete retrofitting. And finally, a rigorous ranking and prioritization step. It determined which of these identified issues were most suitable for developing conceptual plans. So they focused resources where they'd have the greatest impact. It's really a textbook example of transforming an impossible task into actionable steps.
Okay, that sounds very methodical. And those 5 carefully selected subwatersheds what kind of variety did they offer?
Yeah, the report focused on tributary to Rocky Branch, that's subwatershed 244, Rocky Branch itself 246, Dawkins Branch 262, then the Broad Run main stem downstream of Lake Manassas, that's 250, and Kettle Run 272. And these weren't just random picks. They provided a good cross-section of land uses and hydrological conditions across the broader watershed. So, for instance, some represented more urbanized areas, others more rural or protected zones, which allowed the findings to be, extrapolated more effectively to the entire watershed.
Right. So with the soak narrowed down, they hit the ground. What did those critical field inspections find about the stormwater facilities? Were they generally okay, or were there a lot of issues?
Well, the field inventory was pretty thorough. They inspected 33 specific sites identified during that desktop screening phase. And the results, definitely a mixed bag, but they offered clear, actionable directions. On the positive side, 14 out of the 30, so about 41% were found to be in genuinely good condition, which is, encouraging.
Okay, not bad. Over 40%.
Yeah, but the inspections also flagged specific problems. Minor issues included things like a broken fence around a wet pond, some paint seen in one facility, which thankfully was removed quickly, and several facilities just needing minor improvements, like cleaning out their forebays, those initial compartments in a stormwater pond designed to trap sediment. Keeping them clean is vital.
Right, the first line of defense.
Exactly. But more significantly, 6 facilities needed major improvements. We're talking extensive sediment removal or even adding forebays where they were missing. And maybe most alarmingly, 2 sites actually appeared to have been filled in by adjacent parking lots, requiring substantial reconstruction. A clear sign of some past oversight, really.
Wow, paved over. Okay, so definitely some serious areas needing attention there. Were there any surprising or maybe particularly impactful opportunities identified for improvement among these facilities?
Absolutely. And this is where it gets really interesting for future planning. 4 dry basins were identified as excellent candidates for retrofitting. Now, why is this so important? Because retrofitting these facilities can significantly boost water quality treatment. It directly helps meet the EPA's Chesapeake Bay Total Maximum Daily Load goals, the TMDLs, for nutrient removal, specifically targeting pollutants like phosphorus and nitrogen.
Okay, so TMDL, that's the pollution budget we heard.
Exactly. The max amount of a pollutant a water body can handle and still be healthy. Now, these retrofits, they aren't cheap. The estimate for just these 4 projects was around $600,000. But they would collectively improve water quality treatment for over 100 acres of land draining to them. The report also flagged some bioretention facilities, those landscape filter areas in one neighborhood. They needed more study to check if they were really working right. So overall, the estimated cost for the 10 proposed improvements, repairs, and retrofits across the study area totaled around $900,000. It's a significant investment, sure, but one with a pretty clear, measurable return in environmental health.
Okay, that gives us a really clear picture on the stormwater side. But what about the streams themselves, the actual channels? How do they look?
Right. And if we connect this to the bigger environmental picture, this was actually one of the more positive findings. The desktop analysis flagged 22 stream reaches for field assessment, over 19,000 linear feet of stream. And the really good news here, due to the presence of resource protection area, buffers, RPAs, and generally effective stormwater practices already in place, relatively few of the streams in the studied subwatersheds were found to be severely degraded.
RPA buffers. That's the protected vegetated zone along the stream.
Exactly. Typically forested or vegetated, acting as a natural filter, slows runoff, absorbs pollutants, stops erosion, and their effectiveness was just clearly demonstrated here.
That definitely points to good proactive planning then. So, if the RPAs were working, it sounds like not many major stream restoration projects were needed.
Precisely. Only 3 stream and riparian buffer projects were ultimately recommended out of those 22 reaches assessed. These projects would address issues along about 900 linear feet of stream channel, estimated cost. Around $220,000. The cost per foot varied, like $100 to $320, depending on how complex the fix was. Bank steepness, plants needed, engineering involved, but it really demonstrates the long-term cost-effective benefit of those RPAs. Investing up front clearly saved much bigger costs later.
Makes sense. And what about stormwater outfalls? The pipes draining into streams, sometimes those dump untreated water, right?
Yep.
How did Broad Run look there?
Well, this is another positive sign for Broad Run, especially when you compare it to older, more developed watersheds. The study found very few potential stormwater outfall retrofit sites, and the reason is key. Most outfalls were either already being treated by an existing stormwater facility, or they discharged into a healthy wooded riparian buffer that provided natural filtering. So an engineered fix wasn't needed. This is really different from older areas, like Bull Run, where untreated outfalls are a much bigger problem. It indicates most stormwater in Broad Run is getting managed or treated before it hits the streams, a testament to more modern development standards.
Okay, that's reassuring about the stream structure and the outfalls. This suggests some good planning was definitely in place. But, surface assessments can sometimes hide deeper, invisible issues. What did the actual water quality data show? Were there any, silent alarms ringing?
Yes. And here's where it gets really interesting, and we start to see some more nuanced challenges. Water quality data from both the state DEQ and the Occoquan Watershed Monitoring Lab indicated that while Broad Run and Kettle Run had nitrogen levels only slightly elevated over reference conditions, natural, healthy levels, they were significantly stressed by high phosphorus concentrations. And phosphorus, well, it's often a major driver of aquatic ecosystem problems. It acts like superfertilizer.
Superfertilizer, meaning algae blooms, low oxygen, that kind of thing?
Exactly that. It can lead to excessive algal growth, which then sucks oxygen out of the water when it decomposes, harming fish, insects, the whole food web.
So phosphorus is a key concern. Were there any official designations, like those TMDLs we talked about, for these issues?
Yes, absolutely. And this raises the important question about regulatory actions stemming from these findings. DEQ had, in fact, developed a TMDL, that pollution budget for some stream segments in Broad Run, specifically because they weren't meeting standards for fecal bacteria. That points to potential issues with, sanitary sewers or maybe animal waste runoff. And additionally, a second TMDL was developed for a section of South Run, upstream of Lake Manassas. That section was found to be benthically impaired.
Benthically impaired, meaning the bottom-dwelling life.
Right. The benthic macroinvertebrates, the little bugs, worms, crustaceans living on the stream bottom, they're super sensitive indicators of water quality. And they were suffering specifically because of those high phosphorus concentrations. Essentially, the stream's natural cleaning crew and food web base were compromised.
Wow. Benthically impaired due to phosphorus. That paints a pretty clear picture of a stressed ecosystem. But there's a fascinating and kind of complex twist in the report about the Vint Hill wastewater treatment plant, isn't there? Seems like a decision was made that had, well, mixed consequences. What's the story there?
Yeah, this is a really critical point when you connect it to the bigger picture of watershed management and those complex trade-offs involved. The only significant point source of pollution, like a single pipe discharging in the watershed at the time, was the Vint Hill wastewater treatment plant, the WWTP. Now, this plant was actually scheduled to be diverted. Its treated effluent would be discharged into Kettle Run instead of where it was going before. And the fascinating but challenging part. While this diversion was projected to improve the benthic impairment in South Run, it was also projected to increase degraded conditions in Kettle Run.
Oh, wow. So solving a problem in one place potentially creates one somewhere else.
Exactly. It's a classic example of how management decisions, even well-intentioned ones, can shift environmental burdens. It creates new challenges in another spot, requiring extremely careful monitoring and mitigation strategies to prevent unintended consequences. It's a constant balancing act in environmental engineering.
Man, it sounds like a truly complex situation. You've got successes from planning, but also these ongoing challenges, pollutants, tricky trade-offs. So, based on all these findings, all the lessons learned, what were the key recommendations? What was Prince William County's blueprint for the future?
Well, the report laid out several really crucial recommendations, all designed to significantly boost the county's ability to manage its watersheds and, importantly, prepare for increasing federal and state regulations. First and foremost, it strongly advised the county to continue conducting watershed studies. These aren't just one-off projects, right? They provide vital, evolving baseline information. You need that data to respond effectively to upcoming mandates for pollutant removal, like for the Chesapeake Bay cleanup or those federal MS4 permits.
Right, the MS4 permits.
Right.
That's the municipal separate storm sewer system stuff local governments have to deal with.
That's the one. Managing stormwater runoff to prevent pollution. So ongoing studies are key.
Okay, and what about the practical day-to-day management of those stormwater facilities, the ones needing cleaning or fixing? How do they suggest getting a better handle on that?
Yeah, that's a really important question about just operational efficiency and accountability. The report recommended strengthening stormwater inspections and maintenance, and they suggested a three-step integrated process. First, enhance their existing GIS database system to accurately track compliance and the condition of every single facility. Second, actively integrate the inspections into both the GIS database and the maintenance program itself. Make them two sides of the same coin. And third, make the actual maintenance work truly driven by those inspection results, with everything tracked meticulously in the GIS. It creates a much more responsive, proactive, and accountable system, moving away from just reacting to problems towards data-driven prevention.
That makes a lot of sense. It also sounds like they wanted to make sure they protected what was already working well, those successful proactive measures.
Absolutely. The Resource Protection Area Program, the RPA program, was specifically highlighted as a major success. It clearly resulted in the vital protection of those riparian buffers throughout Broad Run. So the recommendation was clear: continue robustly supporting and enforcing this program. Recognize its proven value. They also suggested strengthening the Illicit Discharge Detection and Elimination Program, IDDE.
Illicit discharges. That's like someone dumping oil down a storm drain, right? Stuff that isn't just rain.
Exactly. Anything entering the storm sewer system that isn't just storm water. And the report noted that correcting these discharges, finding and stopping them, is often far more cost-effective than doing large-scale stormwater facility retrofits. Stop pollution at the source.
Good point. And for really understanding those deeper problems, like the phosphorus and the benthic impairment, what did they recommend for ongoing monitoring?
Right. Digging deeper. The report emphasized the critical need for implementing a comprehensive water quality monitoring program, tailored to address the pressing issues in this watershed, but also designed to complement existing state, DEQ, and regional OWML programs. Plus, it needs to meet those MS4 permit requirements, help pinpoint pollution sources, and track improvements over time. And crucially, they also recommended establishing a dedicated benthic monitoring program, looking at those stream bugs.
Ah, so not just chemical tests, but biological monitoring too.
Exactly. Because while chemical tests give you a snapshot in time, those benthic communities, the bugs, they provide a continuous record of stream health over time. They're like the stream's canary in the coal mine. This biological info is vital. It helps the Hugh County track actual improvements in stream conditions from their management actions and helps target where future efforts would be most impactful. It's about looking at both the chemical and the biological health of the ecosystem.
Wow, what an incredibly detailed deep dive into the Broad Run Watershed assessment. I mean, from the huge scale, 73 square miles, down to specific pipe problems, nutrient imbalances like phosphorus, and those complex wastewater trade-offs, it really paints such a rich picture of the challenges but also the successes in managing our vital water resources.
It really does. And if we connect this to the bigger picture, this report isn't just some technical document gathering dust on a shelf in Prince William County. It's a fantastic blueprint, really. It shows how any community can systematically evaluate its natural assets, pinpoint areas needing improvement, and then implement recommendations based on solid data. It powerfully highlights the long-term benefits of proactive planning, like that RPA program, but it also reveals the persistent, often unseen battles against pollutants like phosphorus and the complex choices involved in managing our infrastructure. It's really a testament to the idea that understanding a problem deeply is the absolute first step to solving it effectively.
So what does this all mean for you, the listener? Well, this deep dive might just prompt you to look at your own local waterways with maybe a new appreciation. An appreciation for the science, the planning, the constant effort that goes into keeping them healthy. And it also raises an important question, doesn't it? What invisible systems are at work? Or perhaps desperately need attention right in your own backyard?